Document indexing is PB. Actually, in this document indexing is PB. In this lecture, I will consider total document indexing is PB. In this lecture, I will consider total 3 topics. Single pass in-memory indexing, distributed indexing, and some simple examples of different kinds of index. Now first we will go through the problems with some earlier approaches. Actually, blocked sort-based indexing has excellent sorting properties, but it needs a data structure for mapping the term to term. For very large collections, this data structure doesn't fit into main memory. For example, suppose we have a document D1, and for this, in BSBI algorithm, we store term ID and doc ID into memory. But to convert term into term ID, suppose a term like son occurs in the document, then we first convert into term ID. To convert the term to term ID, we maintain a dictionary This dictionary maps term and term ID. For example, suppose term like son occurs in a document, then we check whether the term son occurs in this dictionary or not. If it occurs, then we just assign its term ID for son. If it doesn't occur in the dictionary, then we put son here and assign some term ID, and we will continue this process. For example, now next document D2 comes, then for terms of that document we will continue this process, and after some time this dictionary's size will become very huge, and it will be very tough to maintain this dictionary into main memory. So this is a major problem of block sort based indexing. Now the second issue is SPB uses term instead of term IDs. Write its blocks dictionary to disk and then start a new dictionary for the next block. Now the next step is, the difference between BSBI and SPB is that SPB adds a posting directly to its posting list instead of first collecting all term ID and document ID pairs and then sorting them. Means it doesn't apply any sorting. So it also saves the memory space and time both. Now some important points of SPME is different from BSBI. It generates a separate dictionary for each block, and thus it does not maintain term ID mappings across blocks, and it does not apply term ID, document ID based sorting, and accumulate posting in the posting list as they occur. It uses the dictionary to generate the complete inverted index for each block. These separate indexes can be merged into one big index. Now we will go through the pseudocode and explain the entire algorithm. So the first step will be in this algorithm, the first step will be first of all we maintain a we maintain a list which contains term and document ID. Now we take document D1, extract the terms. Suppose terms son comes, then we will put as document ID 1, and like that we will continue. And the major thing is we are not going to apply any sorting or any conversion of term to term ID. We just maintain a simple hash file to manage the term and document ID. For each document we will do the same. Now we will prepare a dictionary. This dictionary will contain term and doc IDs. Now suppose document D1 with document D1 the term son occurs. Now we will continue like this. Again at document D5 the term son occurs. Then we will add 5 into the posting and we will continue it. Suppose, for example, after that another term like moon comes and it exists in document 10, and after that again we identify same term in document 11, document 12. If we find that against the moon the posting list is full, then we will increase its size to double. We double the size of this posting list, and we can add some more indexes of documents, and we will continue with this dictionary until we have some suitable space in the memory or the size which we previously fixed. After that, we will take another posting, we will take another posting and another dictionary, we will prepare another dictionary and apply the same process. And suppose after some time we will have, suppose we have total 5 such kind of token list which contains which actually token list is actually dictionary which contains term and document IDs or postings, means in how many documents such terms exist. Actually the main thing is different from BSBI algorithm, we are not going to apply any sorting. So what we will do the next, now suppose such kind of 5 blocks we created. Now the final goal of this algorithm is to create a final indexing. So we will take this final indexing, term document indexing, and we will take some initial part or some starting slot from block 1, and then merge them. After that we find that another chunks are required, then we will take another chunks from this block and merge them. We will continue this style of merging, and finally put with this merging we will put the result into a final index of term and document ID. The major thing of this algorithm is at first step we will identify term and document ID from each document. We will prepare a dictionary. The size of dictionary will depend upon the memory availability or some fixed memory slot that we want to provide for such kind of dictionary or blocks. This block is actually dictionary which contains term and document ID. While we are storing the document IDs, if we find that the size of posting in which we are storing the document IDs is full, then we will double its size, and so that we can continue. And if the size of doc reached the memory limitations or our fixed memory limitation or our fixed predefined size, then we will write that block into disk and we will prepare a next block, and after that we will take some initial data from each block and merge them and continue merging. The data which will be the pick from next block to merge depends upon the index of the next required block, index of the next required data, and then we will check, we will keep simple slots from each block and then continue merging and then write to the final dictionary. So now the entire algorithm is clear. It uses the dictionary to generate the complete inverted index for each block, and these separate indexes can be merged into one big index. It is all clear. And now this is the pseudocode. First is the token string, output file dictionary. We use a hash as a dictionary while free memory is available. Do token, take a stream of document which contains document term and document ID. If token is not a member of dictionary, then posting list, for example, we create a dictionary with this dictionary. Suppose a term moon occurs in a document, a starting document D1, and another term like sun occurs, and if it is doesn't exist into the dictionary, then we will add the sun and document ID to the posting list. Now, if term token doesn't member of dictionary, then posting list add to the dictionary term and token. Else posting list is equal to guest posting list dictionary term token. Suppose a document D3 comes. Suppose a document D3 comes and it again contains the term sun. Then according to this, we will get we just add 3 to the postings. If suppose posting list is full, then suppose we add a lot of terms in this posting list, means suppose sun exists in a lot of documents and our predefined fixed size is full, then we will double its size and add some more terms. And after that, we will sort the entire entry according to the term and put the block into the disk. Sorted terms at posting list. And after that, we will prepare a lot of blocks. Suppose we got a block B1, block B2, block B3, and so on. Now, the next task is to prepare a final sorted index which contains term and document IDs. So we will pick some initial slots from each block, we will merge them, and we will continue by taking next slots from each blocks and finally merging. And after this merging, we will get a final sorted inverted index in the form of term document ID pairs. However, it depends upon whether we can sort all these entries according to term or term ID, term or not. Another thing that can improve the efficiency of SPB is the use of data compression techniques. We can use a lot of compression techniques like LJW or other text compression techniques to minimize the space required by terms, and it will reduce the memory requirement, and then it can increase the block size, and finally we can improve the efficiency or speed of algorithm. Compression of posting, we can also compress the postings. Now another thing is the distributed indexing. Collections are often so large that we cannot perform index construction efficiently on a single machine. This is particularly true of the World Wide Web, for which we need a large computer clusters. To construct any reasonable sized web index, actually web search engines therefore use the distributed indexing algorithm for index construction. The result of construction process is distributed index, that is distributed indexing. Collections are often so large that we cannot perform index construction efficiently on a single machine. This is particularly true for the World Wide Web, which needs large computer clusters to construct any reasonable sized web index. Web search engines therefore generally use distributed indexing algorithms for index constructions. The result of the construction process is a distributed index that is partitioned across several machines, either according to term or according to document. In this section, we describe distributed indexing for term partitioned index. Most large search engines prefer a document partitioned index. Majorly, it prepares the clusters of, it maintains a master machine. Now the architecture, like in distributed indexing, it maintains a master machines which directs the indexing job. This may be like a master machine and several clusters like that. From here, data stream enters into master machine, and master machines distribute the data stream into several cluster machines for indexing. It prepares clusters of machines like that and considers each node of the clusters as safe. It breaks the indexing into set of parallel tasks and passes it into different machines or nodes. Master machines assigns each task to an idle machine from the pool. For example, MapReduce is a distributed programming tool designed for indexing and analysis tasks. Now we will cover some examples of different types of indexings. For that, we have taken total 4 sentences from Wikipedia. Entry for tropical fish. Sentence 1. Tropical fish includes fish found in tropical environments around the world, including both freshwater and saltwater species. Like that, it contains total 4 different sentences. Now we'll show the different types of index construction. The first is simple inverted index construction. So suppose we consider 4 different sentences as documents. Suppose this is from document D1, from document D2, from document D3 and document D4. Then how simple inverted index will look like. For example, aquarium exists in sentence S3 that we considered as document D3, doesn't exist in any other document. Similarly, coloration in 3 and 4, fish exist in all 4 documents, and so on. This is simple inverted index in which we assign the document ID in which the given terms exist. Second is inverted index with counts. Means for example, aquarium. How many times aquarium exists in document 3, D3 or document ID 3. For example, fish exists in document ID 1, count is 2. Exists in document ID 2 also, occurrence frequency is 3. In 3 also, occurrence frequency is 2, and so on. Another is the inverted index with positions. Means what is the position of that word from the starting of the document. For example, this occurs in document D1 at a starting position at position 2. Now we will check this. Position 1, position 2. This is we considered as a document D1. So now this is a position based indexing which stores the term, document ID and position where those terms occurs. It supports the proximity matches. Now there is a simple example how distributed indexing based system generally works. For example, this is a document string. So we parse the document in a string, and the master system which assigns the parsed index to different clusters. Sorry, this is a master system and this is a parser. This is a math page. Means in this parser we will categorize or identify the index sequences and segment them. Now the master system will reduce the computation task by assigning the similar task to simple inverter to prepare the document indexing, inverted document indexing more faster. For example, term which starts from A to F, which starts with A to F, the master system assigns all such tasks through to inverter 1 through cluster system C1, and it creates the inverted index for that posting. For this slot, the Master system assigns task to this inverter, and so on. This step generally reduces the computation task, so we consider it as a reduce phase. In further in map reduce system, we will go through it in more detail.